All right, Chapter 9, Section 6, Day 1. We're going to be talking about solving rational expressions today. Now, there's two up on the board, and we're going to be going through actually off your homework, so pay attention. And this should help us get an understanding of how this is a little different than what we just saw with adding and subtracting rational expressions. You'll need those skills, but we're going to be finishing it off a little differently, okay? So, low battery gone, we're still good, okay. Take a look at this first one. Now this is actually number two, Benito Munoz, on your actual homework. Now, I want you to approach this problem the same way that you would any adding or subtracting. You have to get LCMs, and that's the number one goal here. Got to get an LCM. So look at what we have for our denominators. I got a 3, I have x minus 5, and I have 12. 3, x minus 5, and 12. Well, clearly, neither one of these have an x minus 5. So that's going to be in my LCM. But then look at my whole numbers. I got 3 and 12. What is the LCM of 3 and 12? Well, mental math, hopefully you can get it. 12. So this is what I need all my denominators to become. So give people what they don't have, what they need to get there. What does a 3 need to get here? Well, the 3 is going to need a 4 and an x minus 5. And I'm putting it here because I'm going to apply it to top and bottom, okay? In the middle, it has the x minus 5. It clearly only needs the 12. And the far right side, easy enough, only needs the x minus 5. So that's the first goal. I'm going to rewrite my equation, and I'm going to talk about how this is different, okay? So what I like to do is I like to multiply the 4 and the 7 first, and then distribute the 28. So what that leaves me with is, we get a 28x minus 140 over 12x minus 5. Minus, very important there, this one's kind of nice, it's just 36 over 12x minus 5 equals, we get a 19x minus 95 over 12x minus 5. Okay? So now they all have the exact same denominators. But this is an equation, okay? This is a big difference. It's an equation. Do you notice that all the denominators already agree? They all agree. What we need to do as an equation is make sure that the top is also true. And that's where we get our equation from, okay? So because they all have the same denominator, what we can essentially do is, this is a Gondaman term, schwink, just get rid of it. Now, it's a little misleading. We're not technically getting rid of it, but we don't need it to provide us with an opportunity to find the top to be true. Only the top is going to help us to find the actual solution, what makes this equation true. So I'm going to rewrite what I have. I have a 28x minus 140 minus only 36 equals 19x minus 95. Now keep in mind, if this was like 5x minus 36, you'd have to distribute that negative to both of them. That's been tripping some of you up. Make sure you distribute it to everything in that second fraction if you're subtracting. All right, now, hey, algebra 1. It's just combining like terms and solving. So when I combine, I get a 28x minus 176 equals 19x minus 95. All right, does everybody see I just combined my like terms? So what I'm going to do is I'm going to bring the 176 over here by adding it. I'm going to move the 19x over here. Now this is basic. No one should be struggling with this right now. And we're left with 9x equals 81. Simple math, divide by 9, x equals 9. Now here's a couple things I want you to be careful for. Remember we talked last section about excluded values? Here's what you have to look out for. 9. I need to make sure that that's allowed. So go back to your original. Anybody notice at the very beginning that there was one number that wasn't allowed? What number was it? Hopefully you just said it out loud. 5. Does everybody remember you're still not allowed a 0 in the denominator? 9 does not violate that, so it is not an extraneous solution. That is my first solution here. Okay? It's a quick rundown on how to get it. So again, let's go through it before we do the second one. Find the LCM of denominators. Denominators, yeah, I said it that way. Give them what they need, each fraction, to get the LCM. Schwink, get rid of the denominators, solve the top. Let's do it. Now this one scares a lot of people. It looks weird. This is actually number 5 from your homework. It looks scary because like, oh, all of them are on the bottom. Shh, shut it. Find the LCM. And it actually is a little easier. 6, 6, nothing, so it needs a 6. And a b squared, b and a b, okay, so it needs a b squared. You should all be able to find the LCM of that very quickly. That's not a new skill. We're not reteaching that. That's an old skill that should be learned that will help us do these faster. All right, give them what they need. That needs nothing, so it doesn't get anything. Middle one needs another b, and the last one needs a 6. So I'm going to rewrite my fractions. First one did not change. Second one is just b now over 6b squared. The last one is just 6 over 6b squared. I accomplished my goal of getting LCM. Now, they all have the same denominator. They agree. I need to make sure that the top solves as well. Schwink. You're welcome, Gondo. We get a 1 plus b equals 6. Come on. It doesn't get easier than this. Told you it wasn't scary. Subtract the 1. B equals 5. I don't know why that b had a tail. No, it's not tally. How dare you? Let's check. Does it violate anything? The only excluded value here was a 0. That's allowed. Answer's 5. Quick tutorial on how to solve rational equations when you have very basic denominators. Day 2 will get a little nasty, but for now, enjoy.